Hi, this video hopefully will help explain problem number 3 from the homework on Thursday night. In this particular question, we have a train can travel at a constant rate from New York to Washington, a distance of 225 miles. We then have a new train that travels 50 miles an hour faster and get from New York to Richmond, which is a distance of 375 miles, in the same time as the old train makes to Washington. We are asked here to find the speed of each of the trains. As I mentioned in class on Thursday, what we can do to perhaps organize ourselves and ultimately then help us set up an equation which will help us solve for the speeds is to complete a particular table. In that particular table, we'll want a column for the distance of the trains that are being discussed in this particular problem, a column for the rate or the speeds of the two trains, and then the time for each respective train. Now there are two trains that we have in this particular situation. We have one train that goes from New York to Washington and another train that goes from New York to Richmond. So now that I have this table set up, what we can do is look at each particular train and fill in the relevant information. For the Washington train, we know that the distance from New York to Washington is 225 miles. The rate of that particular train is one of the things we're being asked to find, so I'm going to just write X in for that rate. So as we discussed in class on Thursday, if the Washington train's distance is 225 miles and the rate is X, we know that the time for that particular train would be 225 over X. Now for the Richmond train, we can do the same thing. We can fill in the information we know about that particular train. We know that from New York to Richmond, that is 375 miles. The rate of that particular train will also be asked to solve what that is, but we know that it's 50 miles an hour faster than the Washington train. And so the rate we can write for the Richmond train, we can write as X plus 50. So if the distance is 375 miles and the rate is X plus 50, that means the Richmond train's time would be 375 over X plus 50. So now with this table being set up, we can use this to help ultimately come up with some sort of equation. Now the equation we can use for this particular problem, in the original question, we are told that two different trains at their respective rates and distances, they have the same time. So using the times we've set up in our last column there, we can write that the time of the Washington train, which is 225 over X, that has to be the same as or equal to the Richmond time, which is 375 over X plus 50. And now we have an equation which we can use to help solve for the two different rates. Now you can use any method that you learned in algebra to solve an equation. We discussed methods to solve rational equations, but in this case here, we just have two fractions equal to each other. So what we could perhaps do is just cross multiply. If we do that, we'll have 225 times X plus 50. That equals 375X. We then distribute the 225 into the binomial we have on the left-hand side there, and get 225X plus 225 times 50, which equals 11,250. That still equals 375X. We can then subtract 225X from both sides of our equation to get 11,250 equals 150X. And then last we can divide both sides by 150 to get that x is equal to 75. And this would give us the speed of our Washington train. This would be a Washington train. And since the Richmond train was 50 miles an hour faster, the Richmond train speed would be 125 miles per hour. So hopefully this video helped you understand how to solve problem number 5. I hope that the review sheet that you worked on in class today, you were able to get some work done on that. On Wednesday, we will look at some other types of word problems that are, somewhat similar to what you've seen here. And then on Thursday, we'll review your review sheet from Friday and go over any questions you have for your test on Friday. I hope you have an awesome evening. Take care.